Okay, here are a few more antiderivatives that just stem from knowing our basic derivative rules, and these all relate to the trigonometric functions. So what do we know? Well, what we know is that the derivative of sine x equals cosine x. Therefore, the integral of cosine x should go back to sine x. We know that the derivative of cosine x is negative sine. So if we just swap this negative to the other side of this equation here, the integral of the sine x would be equal to negative cosine. Those should be the easy ones. I think everyone gets those down pretty quickly because you've done the derivative so many times. Now, the other four trigonometric functions, you've seen the derivatives a little less, so you're going to have to work harder to commit these to memory. I really think using index cards is probably your best bet, and just keep flipping through them and you get these committed. It's going to benefit you greatly as you go through your calculus courses, as well as your other courses where you're going to need derivatives as well. So anyway, we know that the derivative of tan x equals secant squared. So the integral of secant squared should equal tan x. The derivative of secant x equals secant x times tan x. So the integral of secant x times tan x equals secant x. A couple more. Derivative of cotan equals negative cosecant squared. So the integral of cosecant squared equals negative cotan. The derivative of cosecant x equals negative cosecant x cotangent x. And therefore cosecant x cotangent x equals negative cosecant. And with these negative ones, remember, you just kind of have to flip the negative over to the other side, here, here, and here. And that's kind of where it comes from in the answer. So once you know these basic integral rules, and you should know them fairly easily because you should know your derivative rules, we could do a couple of examples. Now notice, we have yet to say what is the integral of just secant x dx. We have the integral of secant squared, we have the integral of secant times tangent, but not just the integral of secant by itself. Also, we don't know what the integral of, say, tangent x is, or cosecant or cotangent by themselves. And why is that? Because we don't know necessarily what the derivative, what this is the derivative of, okay? Or what this is the derivative of. And we won't until we get into something called U substitution. So soon we will learn these integrals. But notice none of them are just the four basic trig functions, secant, tangent, cosecant, or cotangent. They're based off of the derivative rules, and so we have secant squared, or secant tangent, or cosecant squared, or cosecant cotangent. But we will eventually get to these as well. We need a little bit more work in antiderivatives to be able to do that. So here, this should be a very easy one. The 2 is a constant multiple. We just have the integral of sine x dx, and the integral of sine is negative cosine, so we get negative 2 cosine x plus c. That's simple. If you know your derivative rules, you then also should know your integral rules, and then doing some of these integrals is very easy. And this is the only way to do these integrals, is to know the answer based off of the derivatives. So this next one's a little bit more. We will actually have other ways to do this integral in the next lesson or so. But for right now, what we need to do is, in order to be able to evaluate this integral, we actually have to rewrite it a different way. Because we have to say, what is this the derivative of? Now the problem is, it's not something you would just know off the top of your head. But if I rewrite this function a little bit, and I write it as sine x over cosine x, times 1 over cosine x dx. Okay? Then I write that as sine x over cosine x is tangent x, and 1 over cosine x is secant x. Then I have something that I should be able to work with. Tangent x times secant x is the same thing as secant x times tangent x. They're multiplied together, so the order doesn't matter. You can swap these back and forth. But that is a derivative you should know. That is the derivative of secant x plus c. So there's your integral. Again, we will have another way we'll be able to get the answer to this integral in the near future. But for right now, that's it. Okay, that's the best way to do it. So sometimes you need to use some of your trig identities, rewrite the function a little bit, and try and turn it into one of those basic antiderivatives that are based off of our simple derivative rules. All right, here's another one again. As long as you know your basic rules for integration from antiderivatives and derivatives themselves, this is easy. 5 is a constant multiple. These are subtracted. I can do this integral separate from this integral. So we have 5 times the integral of secant squared x dx minus the integral of cosecant squared x dx. And so secant squared is a basic integral, cosecant squared is a basic integral. So we would have 5 times tangent x, okay, minus the integral of cosecant squared is minus cotangent x, plus c. These two negatives will cancel out and give me a plus, so I have 5 tan x plus cotan x plus c. And the only way, again, to do this would be to know this integral and this integral. So pure memorization is the way you're going to have to get this done.